Today's daily dose of math is about the ratio of volumes, ratio of two volumes. A question can be asked where a student is given a couple of three-dimensional shapes and asked to compare two of them and give the ratio between their volumes. I've had students of mine be very confused and overwhelmed by this question. They end up leaving it blank. It's as if they just don't understand the question, but it actually is not a very difficult thing for them to do. The ratio is just a comparison of two numbers. If I'm twice as tall as you, then the ratio between our heights is 2 to 1. Or if you want, you can say it's 1 to 2. Okay, you're half as tall as me, that's a 1 to 2 ratio. I'm twice as tall as you, that's a 2 to 1 ratio. So just putting these two numbers into a ratio is not a very challenging thing after all. But I'm going to give the ratios of two volumes 3 times as examples in this video. So we have three shapes, a cube, a cone, and a cylinder, and they are labeled as A, B, and C. And in 3 different questions we're being asked, what is the ratio between the volumes of A and B, of A and C, of B and C? So there is a little bit of work to do here. It's not just as simple as writing two numbers together, which would be nice, but math questions have a way of making you do a bit of work to earn the right to answer the question. So we have to do some volume formulas. The volume of the cube is s cubed, side length cubed. In this case, it's 3 cubed, which is 27. And because it was 3 centimeters, the unit will be centimeters cubed. I still don't have enough information to answer this though, because I only know one of the volumes. So the volume of B is the volume of the cone. That is pi r squared h over 3, which in this case is pi 5 squared 12 over 3. The 12 and the 3 cancel to give a 4. 5 squared is 25. 25 times 4 is 100. So this is 100 pi. And then using my calculator, I find that 100 pi is equal to 314.2 centimeters cubed, of course. So the ratio is 27 to 314.2, or if you prefer, 314.2 to 27. Both of these are ratios between the volumes of A and B. Now we can do A and C, and it'll be a little bit less work because we've already done the volume of the cube A. So we need the volume of the cylinder C. The volume is pi r squared h, which in this case is pi 5 squared 12, because I happen to have given the cylinder the same radius and the same height as the cone we had for B. That's going to be 300 pi, and therefore it's equal to 942.5 centimeters cubed. Now these volumes of the cone and the cylinder were rounded off a little bit. And the ratio therefore is going to be 27 over 942.5, or 942.5 over 27. Now we're asked for the ratio of the volumes between B and C, the cone and the cylinder. Well, I've done all of the work already for the volume of the cone and the volume of the cylinder. And the ratio is going to be 314.2 over 942.5, or, if I wish, 942.5 over 314.2. But because those numbers were rounded, this is a complicated looking answer that is masking the reality, which is that this fraction actually reduces to 1 over 3. And this one reduces to 3 over 1. And if we hadn't rounded, it would be easier to see that. But that reveals something else about the relationship between the volume of a cone and the volume of the cylinder when they have the same radius and the same height. So I'm going to answer this B and C question again in a different way. First, I'll erase the first two answers. And now, let's look at the volume formula with the values plugged in but not simplified. So the volume of the cone is pi 5 squared 12 over 3. And in a ratio, we put one of the numbers, which would be this volume, in the numerator, and then we put another number in the denominator. The other one is going to be the volume of the cylinder, which is pi r squared h, 3, 2, 1, which is pi 5 squared 12, and if I want to express that as a fraction, I can put it over 1. So this is a division. And when I divide fractions, I can show it this way, which looks kind of complicated, or instead I can show it like this. Pi 5 squared 12 over 3 divided by pi 5 squared 12 over 1. But of course, when you divide fractions, you multiply instead and you turn the second fraction upside down. So it's pi 5 squared 12 over 3 times 1 over pi 5 squared 12. Well, now we can simplify. The pi's will cancel. The 5 squareds will cancel. The 12s will cancel, and all we have left is a 1 on the top and a 3 on the bottom. And of course, if we had done this whole thing upside down, we would have had a 3 on the top and a 1 on the bottom, just like these answers here. So what this is revealing, or reminding us of, is that the volume formula for a cone is the same as the volume formula for a cylinder, but the cone one is divided by 3, the cylinder one is not. And the reason for that is the volume of any cone that has the same radius and height as the cylinder will always be exactly 1/3 the volume of that cylinder. So we see a relationship between the formulas, and because this cone and cylinder happen to have the same height and radius, we of course get a 1:3 ratio or a 3:1 ratio. That is today's Daily Dose of Math. Please like, subscribe, and share.